Namaste, friends. You know that feeling, right? You're trying to connect your AI to some tool, and it feels like you're digging through a drawer full of old, tangled cables, just looking for the right one. Ugh. Well, today, we're gonna fix that. Let's dive into the solution.
Okay, so here's our game plan. We'll kick things off with the big aha idea. Then we'll get into the nitty-gritty of how it all works. After that, we'll look at some actual Python code, get you prepped for any interviews, and wrap it all up with a super clear action plan. Ready? Let's go.
All right, first things first. Let's talk about this genius idea right from the official documentation. Think of MCP as the USB-C port for AI. I mean, how perfect is that? It's this single, standard way to connect your AI models to all sorts of tools and data. This one concept, this is the key to why the Model Context Protocol, or MCP, is such a massive game changer.
So you got to understand the problem it's solving. Before MCP came along, hooking up your LLM to, say, a database or some random API, my God, it was a nightmare. You had to write custom one-off code for every single connection. It was this tangled, brittle mess that was impossible to scale. And honestly, it was a huge headache. It was like inventing a new weird plug every time you bought a new device.
Okay, so that was the mess. The question is, how does MCP actually clean it all up? Well, let's get into the core building blocks and see how it brings some much-needed order to the universe of AI agents.
So what is it, really? In the simplest terms, MCP, the Model Context Protocol, is just a common language. Think of it like a universal rulebook that lets your AI agent chat with any tool out there without needing a special translator for each one. And because it's an open protocol, anyone can jump in and build tools that speak this language. It's all about standardization.
Okay, this is where it gets really clever. MCP splits the whole system into two main parts. On one side, you have the MCP server. This is where your tools live. It's the thing that exposes your database connection or your API access, whatever. It's the tool shed, you could say. And on the other side, you've got the MCP client. This little guy lives inside your AI application, right next to your agent, and acts as the bridge. It's the one that goes to the tool shed and gets the right tool. It's a really clean separation of concerns.
And here's how it all fits together. Look at this flow. Your LLM and the agent runtime, they don't talk directly to the messy outside world of APIs and data. No way. Instead, the agent talks to its MCP client. The client then talks to the MCP server over that standard protocol. Then, the server is the one that actually deals with the external stuff. You see that? This creates a beautiful, clean boundary. It's absolutely crucial for security and for being able to scale things up. So, when an agent wants to actually use a tool, what happens? Well, it's this really neat four-step dance. Step 1, discover. The client basically asks the server, hey, what tools you got for me? Step 2, select. Based on your request, the LLM looks at the list and picks the perfect tool for the job. Step 3, call. The client sends a formal request to the server saying, okay, use this tool with these inputs. And finally, step 4, handle result. The server does its thing, runs the tool, and sends the answer right back to the agent. Discover, select, call, handle. Super logical. All right, that's enough theory for now. Let's get our hands dirty and see what this actually looks like in Python. Time for some code. Okay, friends, check out this code. This is what it looks like from the agent side. We're creating an agent here. We're calling it Finder. Now pay close attention to this one line. Server names equals file system. This is the magic right here. We're telling our agent, hey, you have permission to talk to the MCP server named file system. That's the connection. From there, we just give the agent a task, like show me what's in readme.md. And the best part, the MCP agent library takes care of that whole four-step dance. Discover, select, call, handle. All of it happens automatically for us. So clean. Okay, so using tools that someone else built is cool. But what if you want to create your own tools? That's where MCP gets really, really powerful. So now let's flip the script and look at the server side. You're going to love how simple this is. Seriously, look at this. With a library called FastMCP, it's almost ridiculously easy. You just write a plain old Python function. See this one? Def add. Nothing fancy. But the secret sauce is this little thing right here, the ad-MCP tool decorator you put on top. And that's it. I'm not kidding. This normal Python function is now a full-blown tool that any MCP agent can find and use. And here's the really clever part, the docstring. Add 2 numbers. That automatically becomes the description the LLM uses to figure out what your tool does. How cool is that? And of course, this isn't just for simple math, right? Think bigger. Imagine you build a research agent. It could tap into a Google search tool running on one server and a fetch content tool that reads websites running on a totally different server, maybe even in a different company. And your agent can use both of them together to answer a complex question like analyze the impact of AI. It's all possible because they all speak that same universal language, MCP.
Okay, let's totally switch gears for a second. Let's get you interview ready. Imagine you're sitting across from the hiring manager and they start asking about AI agents. Here are some quick, confident answers for you.
All right, first question they might throw at you. What is MCP? Your answer? It's an open protocol that standardizes how AI agents use tools. Basically, it's like a USB-C for AI. Boom. Next, what's the difference between a server and a client? Easy. The server exposes the tools and the client connects the agent to those tools. And the big one, why use it over a direct API call? Your keyword here is interoperability. With MCP, any agent can use any tool, making the whole system plug and play without writing custom code for everything.
Okay, now for a couple of how-to questions. They ask, how do you add a new tool to an MCP server? You say, with a Python library like FastMCP, you just write a function and add the ad-mcp.tool decorator. Simple. Then, how do agents discover what tools are available? The answer is, the MCP client sends a standard discovery request, like tools/list, and the server sends back a full list of its tools and what they do. See? You sound like you know exactly what you're talking about.
All right, you've absorbed a ton of information. That's awesome. But knowledge is only useful when you apply it. So what's next? Let's put together a real action plan.
As you start building your own tools, keep these 3 best practices in mind, straight from the official sources. First, your tool design. Use super clear names and descriptions. Remember, the LLM is reading these to decide what to do. Second, your schema. Define exactly what goes in and what comes out. This will save you from so many headaches. And third, reliability. Things will fail, so build proper error handling right into your tools so the agent gets a useful message back, not just a crash.
Look, the absolute best way to make this stick is to try it yourself. So here's a little challenge for you, something you can do in the next 30 minutes. First, install the libraries. Second, copy-paste that minimal add tool server we looked at. And third, test it. Use the Python SDK to connect to your own local server and call that tool. I promise you'll have that aha moment when you see it work. So, I want to leave you with this one final thought. If tools are the hands and feet of an AI agent, giving it the ability to actually do things in the world, well, we've just given them a universal language to coordinate all those actions. The possibilities are literally endless now. So the question is, what will you build? Hey, if this explainer helped you out, do me a huge favor and hit that like button. Share it with anyone who might find it useful, and of course, subscribe for more breakdowns of complex tech topics. Thanks so much for watching.